So at Lon 5 we're using indirect air cooling technology. So essentially it's an all-air system which takes the outside air and uses that to cool the recirculating data hall air, but it does it indirectly, so you never get outside air coming into the data centre. So there's plate heat exchangers in the air handling units with adiabatic cooling as well to assist in peak summer months. The plate heat exchangers are plastic material, so that allows the outdoor air to travel through and across the indoor air, the recirculating air, and it transfers the cooling energy from the outdoor air into the indoor air without actually mixing the air paths. The adiabatic part is where, if it's hot in the summer, we have sprays within the units which adiabatically cool the outdoor air, so they take it from a peak summer temperature of, let's say, 35 degrees C, and they'll cool that down, and that assists with the cooling.
One of the principal changes that have taken place that's allowed this technology to become viable is the opening up of the environmental conditions within the data hall itself. There is a standard, it's published by ASHRAE, which is TC 9.9, which recommends conditions for air entering the server. Over time, what ASHRAE has been doing is increasing the allowable temperature at the inlet to the server.
They've been doing a lot of work with the vendors and server vendors. They're expanding that envelope, increasing the supplier temperatures and expanding the humidity range, which then really allows the engineers to adopt different technologies and make them more efficient. And in this case, we're using indirect air cooling technologies.
If the temperature in the room is warmer, then that increases the possibilities of free cooling using outside air, and that's a change that has been taking place over the last 5 to 10 years. A principal improvement in the efficiency is due to the absence of compressor power. If you were to compare this facility with a traditional data center using chillers and crack units and chill water pumps, if you compared the energy profiles, you'd see that the biggest user of energy besides the IT power is the cooling power, and a big chunk of that is down to the compressors that serve the chillers. Well, in this facility, we don't have any compressors, we don't have any refrigerant. The only energy that we're using to cool the data center is the fan power associated with the indirect air cooling units and the water pumps that supply the water for the evaporative cooling. The evaporative cooling process that we use during the peak summer period is dependent upon this water supply. We're using the water sprays on the indirect air before it goes into the heat exchanger to get that cooling effect. So we need to have a very good supply of water to make sure that that cooling process is maintained. Because we can't rely upon the grid supply, the utility water supply, we have to have on-site storage. And in this facility here, we have some fairly large underground water tanks that are there to hold a 24-hour supply of processed water in case the main supply should break down. With a more traditional data center, the architecture of the space is generally revolves around what are called crack units, computer room cooling units, and they would supply air via a raised floor void, and then the air would be supplied into cold aisles via floor grills. What we have here at Lon 5 is what's called flooded room with hot aisle containment. So the air is supplied into directly into the room via plenum walls that run down either side of the data hall. The whole room is then cooled, and the hot aisle is contained so that the cool air passes through the server racks into the hot aisle and then rises up into the ceiling void and is returned to the indirect air cooling units. It's one of the first sites in the UK of this scale using indirect air technology. And to do it on this scale, I think is quite groundbreaking, and to be associated with that is, as an engineer, is very exciting.